All right, so we're going to start chapter 13 with the time value of money. And the first thing that we're going to take a look at is we're going to take a look at interest. And there's two different types of interest we're going to look at in this section. The first one's called simple interest. It is the easiest one to find. I don't think that's why it's called simple, but it is easy to find. And then the other kind of interest is called compound interest. And I know without a shadow of doubt you have found both of these before, but you may not have seen the simple interest formula written out this way before. It's not always presented in this way. So we're going to start with simple interest. Simple interest has a formula that looks like I equals PRT. The P, the R, the T, they're all multiplied together. And I is the interest amount. It's the amount you make in interest. P is the principal. Principal is the amount of money you put into an account or borrow from somewhere. Okay. R is your interest rate as a decimal. And T is your time in years. All right, so as we're working with these interest problems, principal can be done in one of two, or can be, not principal, the interest can be thought of in one of two ways. And it's all based upon the principal. There's two different kinds of things we're going to be talking about. We're going to be talking about saving money. That's putting money into an account, putting money into something where you're saving it, you're not going to be touching it. The other option is where you're borrowing money and paying something back. Both of those situations, the initial amount that you either put in or that you borrow from that organization is still called principal. It doesn't make any difference whether it's a loan or whether it's an investment. Still principal. Okay. The interest rate as a decimal, it's an easy mistake that people forget sometimes. So if we had a 7% interest rate, we don't put 7 in for R. What do we put in for R? 0.07. So you remember when you change something into the decimal, you move the decimal point how? 2 places, which way? Left. 2 places to the left. All right, and then the time in years, again, an easy mistake to overlook. And we actually see time mentioned in lots of different contexts, in real life contexts, not mentioned in years. For instance, when was the last time you heard a car loan said that it was a 4-year loan? They don't usually say that. What do they usually say? They usually say 48 months. So you need to be careful that whatever unit you're given, you put it into time before you stick it into this formula. Okay? So it's an important consideration. Now, future value is the amount you have in the future. It sounds like what it is, okay? There's two different formulas. I'm going to write them both down, and we're going to talk about how they're related. And then we're going to talk about why we might want to use one versus the other when they really are the same, okay? So they're going to be written as A equals. I don't know why we use A. I've actually used some books that will call this FV for future value. That would be nice. Your book's using A, so we're going to stick with A. It is the more common used as well. One formula says P plus PRT. The other formula says A equals P, and then it has a parenthesis 1 plus RT. Okay, so first issue, how are those two formulas related? Why are they the same?
The second one is just when you multiply it, it's
Yeah, there's a key word. Do you remember? It's not factored. If you were to take the first one and factor it, it would become this. If you were to take the second one and turn it into the first, what would you do? Distribute is usually the word we hear. Okay, so yes, it's factored from the first one, or it's distributed from the second one back to the first. All they've done is they've just sort of multiplied this through, right? You multiply P times 1, you get P. Multiply P times RT, you get PRT. So obviously, they're the same formula. Agreed? Okay. Now let me talk about them from which one we might want to use perspective. The first one conceptually is a great formula, and here's why. This says the amount that you're going to have after 5 years or whatever, or the amount you will have paid for that car after 5 years or whatever, is equal to the principal, that is the first amount you initially had, okay, plus what is PRT? That's the interest. All right, so the final amount is the initial amount plus the interest. Well, yeah, right? I mean, that makes sense. So I conceptually look at the first one and say, I get where all those pieces came from. Now, you guys have already looked at the second one and said all we've done is sort of plucked the number P out in front. I mean, I get that too. The second one is actually really helpful if all you're interested in is finding the final amount, not the interest first and then the amount. This one allows you to do that more cleanly just because there's fewer steps to it. I only multiply once, whereas here I would have actually had to add something and multiply in a different order. It doesn't matter. You can use either one of them, okay? But you do have two options. All right, we're going to take an example. We're going to talk about Paul. And Paul actually paid too much on his taxes. Shame on Paul. And so the IRS owes him money. He is owed $530 by the IRS for overpayment of his taxes. And the IRS is going to pay him money back, the initial $530 that he owed, right, or overpaid. And then they're going to pay him an amount of 4% interest on that money. Now, the thing I want you to get in the habit of doing in this particular chapter is highlighting, underlining, circling something what the question is asking. Because we're going to have a lot of formulas. And if you use the wrong formula, you're going to lose most of the points in the problem because you didn't understand what they were asking. Every problem is going to tell you exactly what to find. You just need to make sure you read the problem carefully to find what you're asked to find. Part A here says find the amount of interest owed to the IRS. Owed from the IRS to Paul. So the question is asking for his interest, right? So I've already written down 3 formulas on the previous slide for you. One of them is the one I want, and the others are not. Which formula does this ask you to use on Part A? The top one, because it says how much interest is he owed. Not what's the final amount. We're going to get to that question in a minute, but how much interest is Part A? So I'm using I equals. I'm going to go ahead and write it in all right here since I don't have it on my screen right now. I equals PRT. What we're finding is I. What is P in this problem? That's the 530. It's the initial amount that he overpaid. It's the principal. What is R in this problem? 0.04. You bet. Okay, so make sure we changed it into a decimal, not into the same percent that it started out as. And then the time.
1 year.
1 year, because he did it last year, right? All right, so we grab a calculator, which you should have with you. If you do not have a calculator with you, you need to be bringing it every day.
I already took care of the interest amount.
Good, sorry. Did everybody have, so everybody have their calculator out if you have it with you. If you don't, just bring it next time. You're going to take 530 and you're going to multiply by 0.04. What do you get? 21.2. It's a dollar amount, good.
That's $21.20.
20 cents. So it's 0.2, like Trent said, and we're going to put 20 because we're talking about money. We usually represent things with 2 decimal places if we've got cents at all, and we do. I don't mean like common cents, I mean like money cents. If we have pennies and coins at all, we represent it with 2 decimals, so we're going to do that for these, okay? With dollar signs, and I promise you I'll take off if you don't put dollar signs in. I know that sounds really mean, but I'm warning you in advance. Just you put your dollar signs and everything, okay? You're going to need them on almost every problem in this chapter. All right, so that's Part A. That's how much interest the IRS owes Paul. Now, because we've already found the interest, we have some options on Part B. How could we find the total amount the IRS owes Paul? What do we want to add, Katrina?
The interest that we found.
Which was
how
20.
much they owe me.
Okay, so we could add the 2120 and that 530, right? And that's actually using, whether you recognized it initially or not, that's actually using one of the formulas. This piece right here is the PRT part, and this piece is the P part. It's the first formula that I had over here underneath A equals P plus PRT. It's the principal plus the interest. And we found the interest, so we could simply add the principal and the interest together. And if we did, how much would we get on this problem?
The grand total is $551.20.
Right. Now, let's suppose for a moment that for some reason we didn't think to use this formula, or maybe part A didn't happen. There wasn't a part A to the problem where you already found the interest, and you wanted to use the other formula. I would like to show you that you really do get the same thing and show you how that process looks. So this formula looks like this, right? So if you wanted to use this formula, you'd put that 530 on the outside. You'd have the 1 plus on the inside. Your interest rate's still 0.04. And your time is still 1 year. Now your calculator, most of your calculators can handle you entering this exactly like it is, but it doesn't hurt to simplify a little bit before you start if you'd like to as well. And in fact, some cases we're going to have to. This is just 1.04, right? On the inside. So your calculator can take 530 times 1.04 and it will give you what?
551.2? Exactly.
Exactly the same value, right? So it doesn't matter which one you use, you're going to get to the same spot in the end. Okay, any questions on that? You've used interest before. You may not have thought about it in quite this sort of specific way, but you've done this before. Now, even more specifically, I know you've seen compound interest, okay? So compound interest is interest that compounds with regularity. So it compounds something like annually, semi-annually, quarterly, monthly, weekly, daily, etc. And the first thing you're going to notice is I'm not going to give you an I equals formula. There's not a direct formula. Your book doesn't use one. What you're going to get, however, is you're going to get that future value formula, that A equals formula. So I'm going to start with that, and then we're going to go back up a little bit and talk a little bit more about the compound interest details. A equals, well, it's got a P and it's got a parenthesis. That looks familiar, right? Even better, it's got a 1 plus. Also very familiar. Now, I will tell you, I'm about to deviate from what your book does. And the reason I'm going to do so is because if you've seen compound interest before, and most of you should have seen it in an Algebra 1 or an Algebra 2 class in high school. Okay, that's where this is usually done. I'm going to show you the formula that you've seen. Okay, your book teaches you a different formula. I don't think that that's really helpful to change the formula on you right now. What you do next is you take R and you divide it by N. And you close your parentheses. And then you have an exponent. Now that's new. We haven't had that yet. The exponent is NT. Now most of these pieces we've already used. We used them with simple interest. P is what? The principal. R is the interest rate as a decimal, right? N, that's a new letter. We'll come back to that in a minute. And T is time in years, always in years. Now let's talk about N, which is what it talks about up here in parentheses. The N that it talks about there in the parentheses is the number of compoundings per year. Okay? So if you compounded something annually, how many times a year would that happen? Once a year. Annually, right? Semi-annually, all of those who like to shop, what does semi-annual mean? Twice a year. We usually hear the phrase semi-annual sale, right? It means it happens twice a year. Semi-annually is twice a year. What does quarterly mean? 4 times. Despite popular opinion among small children, a quarter does not mean 25 cents. Quarter does not mean 25. The reason we call it a quarter is because it's worth 1/4 or a quarter of a dollar. Hence the reason that when we talk about a quarter of an hour, it's not 25 minutes, right? So quarter means 4. Monthly? 12. Weekly? 52. And then daily?
365 or 366,
Right.
depending on the year.
And we're going to use 365 because that's the most prevalent. So we're not going to worry about the quarter of a year that happens every, we're not going to worry about any of that stuff. So it's just going to be 365. So if you see something daily, you're going to use 365. All right, so this is the formula we're going to use. Now, we're going to use a little bit of caution when we use this formula because it's really easy to screw things up in your calculator if you're not being extra careful. And here's where it usually happens. It usually happens in the exponent. So anytime we work with these problems, the first thing we're going to do is we're going to actually multiply that exponent together. We're not going to put it in the calculator as a multiplication factor. And the reason is this. Undoubtedly, at some point, if you try to do that, you're going to mess up the parentheses. And if you do, your calculator is going to think that you want to do all of this first and raise it to the nth power. And then it's going to multiply that whole result by t, instead of t being part of the exponent. And you will get a large value that's unreasonably large if you do that, because it's incorrect, all right? The easiest way to avoid that is to not worry about the parentheses, but simply to just multiply the exponent out. It's usually small numbers you can do in your head anyway, so that's what we're going to do. All right, let's take a look at an example. All right, we're starting with a table. The table says that we have a principal of $7,500. The interest rate is 3.5%. It is compounded semi-annually. What does that mean? Twice a year. And then our time is 25 years. And we're asked to find two things. We're asked to find the final amount that's in that account, and then the compound interest that actually accrued during that 25 years. Now, like I told you, we don't have a formula for compound interest. I'll show you what we do when we get there. If you haven't already sort of thought through that, it's okay. But we're going to start with the final amount, because I have a formula for that. Okay? So the final amount says that I do A equals, what comes first? P, which is the 7,500. The principal, 7,500. And then I have a parentheses with the 1 plus. Then what? The interest rate. What's the interest rate, Colt? 3.5. So how do I write that as a decimal? Close. 0.035. So 3.5 is already a decimal, and then we've got to turn it, but it's a decimal as a percent, 3.5%. So then to turn that percent into a decimal value, we're going to still move the decimal to the left. Then this is going to be divided by what? 2, right? Because it said semi-annually, so n equals to 2. And then I'm going to raise it to what power?
2 times 25.
2 times 25. 2 for the n value, 25 for the number of years. And again, like I told you, you can do that in your head, and almost always you can. 2 times 25 is 50. All right, so we're going to do just a little bit of simplifying just because we can as we're working here, and because some of your calculators are going to require it of you. I know my exponent's 50 here, right? We already said that. This piece that's in parentheses. Now, some of you can just enter this straight into your calculator, put the 50 right here. If you have the TI, like, hold yours up, Austin. If you have a calculator like this, the TI 84, 84, 82, 83, those versions, they'll allow you to put all the parentheses in and whatnot. Leah, hold your calculator up. If you have a scientific calculator, some of them won't let you do that. So I want to show you, if you have a scientific calculator, what you have to do in order to make this cooperate with you. You've got to find out what this piece is in the middle. Okay? So where do you start? You start with the division piece, because division happens before addition, order of operations, right? So everybody can do this with your calculator, even if you have the nicer calculators to do the graphing, which we don't need that feature, but still do this with me. I want you to take the 0.035 and divide by 2. Okay, so you've done this piece right here. And then I want you to add the number 1. Okay, now this time, not always, but this time that actually ends up being a terminating decimal, it stops. What does it give me, Sarah?
1.0175.
Okay, does that look good to everybody else? Okay, great. Now your calculator will deal with this just fine. Again, if you have a scientific calculator, you need to make sure that you, as the operator of your calculator, are observing order of operations, which means what are you going to do first? Are you going to multiply, or are you going to do the exponent first?
Exponent first.
Exponent first. Guys, remember that? Okay. So this piece right here is the part you'll do first. You're going to keep that 1.0175 from your calculator from before, and simply hit either there's a caret key that looks like this, or you've got a key that says something like x to the y.
Or y to the x.
Maybe y to the x. So you're looking for a key that sort of looks something like that. Okay? So you've got this number, and you're going to push that button, whatever it is, and you're going to put 50 in after that. It's going to give you an answer that is no longer going to be a terminating pretty decimal. It's going to look really ugly. That's okay. Just let your calculator have this little decimal expansion right there, and then you're going to hit times 7,500. Do not round until the end. You will lose accuracy if you round too soon. So If I hit then the times 7,500, what do I get? What do you get?
17,855. 0.916.
So 0.92 if we round to 2 decimals at the end, right, Trent?
Yeah.
Yeah. And we do want to round to 2 decimals at the end because this is money. So we're going to be using 2 decimals all the way through this section for money. So this is the final amount. So if you went today and you put $7,500 in a bank that gave you 3.5% compounded semi-annually and you didn't go back for 25 years, when you went back in 25 years, that money would have grown to $17,855.92. Okay? So that value right there is what goes in that first blank. All right, second blank, compound interest. How can I find out how much interest that was then?
25 years.
That amount minus the
All right, so this amount is the total amount I have when I go back to the bank 25 years from now, right? But initially, I know how much I put in. It was $7,500. So if we take that final amount of the account and we subtract the initial amount that we put into the account, then everything else was the interest that happened while it was sitting there and me not touching it. So our interest would be the $17,855.92 minus the $7,500. And what number does that give you? It's 10,000 something, right?
2035.
And 92 cents. And this value would go in the compound interest box. So there's not a formula, but there's certainly a way to find it, right? We just subtract the original amount from the final amount. Okay, any questions on this one? Okay, we're going to take a look at a problem that goes a little bit differently. This problem says, example, find the present value for the future amount. Now, that's a phrase we have not encountered yet, present value. Present value is another word for the principal. Present value is the amount that it currently is worth. Future value is the amount it will be worth sometime into the future. So this would be the idea that if you knew you were saving for some big ticket item in just a savings account, you know, it's a car or it's an iPad or it's a whatever, okay? The question is, how much money should you put back now to make sure that it grows with the interest to that amount into the future? That's the idea. Okay, so we're going to find how much should I put in today to have that amount into the future. And the problem says that I have $9,860. That's how much I want to have in an account that's compounding 8% quarterly for 10 years. So I'm actually going to take the exact same formula that I had before. A equals P times 1 plus R over N to the NT. Same formula. And I'm going to fill in the pieces that I know. So let's start with that 9860. Where will that go? Right. That's the A. That's the future value amount that I want to have. So it will go on the left-hand side of the equation. P is what I don't know, right? It's what I'm looking for. So it will remain as P. 1 plus, those are all already there. What is the R? 0.08, thank you. What is N? 4, because it said compounded quarterly, right? N is still 4. What is T? 10. So this is 4 times 10, so the exponent is 40, and your calculator didn't need to tell you that, right? No, it didn't. Okay. All right, good. So let's take a look and simplify a little bit before we get our calculator involved. I've got P, I've got a parenthesis, and I simplified with the 40. Now, if you'd like your calculator, you can grab it. Most of this you can probably do in your head. But we've got to do work on this piece and to simplify it. So what is 0.08 divided by 4?
102.
0.02 plus 1?
1.02.
1.02. Okay? Now, this will not always work out to being a nice, pretty number. We'll see another example that it doesn't in a minute, but that's okay. Now you're going to take the 1.02 and you're going to raise it to the power of 40, and it's going to look ugly. Okay? So find out what it looks like. Yeah. Lots of decimals, and it doesn't have any particular pattern as you're looking at them right now. So here's what you're going to do. You're going to write down a whole bunch of them. Okay? So what do I mean by a whole bunch? Like 6 or 7 decimal points. Don't round too early. Okay? So let's go with 7. We're going to err on the side of more. More is always better. So we're going to err on the side of more. So Brittany, I'm going to have you tell me the first 7 decimal places.
2963055.
All right. Okay. And it really, if you round the last one up or down, I don't even care. It's not going to matter. Okay?
I get 2.208039664.
Oh. Okay, we got a slightly different answer. Try it again, Brittany. Make sure it works out on yours. But Holly, what did you say? 2?
2.2080396.
Okay. Did it work out, Brittany?
I think we can go with that. Whatever happens.
Okay, so taking a look at this now, you've got some simple algebra to do. How in the world are we going to solve for p? Say it louder, Laramie. We're going to divide. This p and this 2 point whatever, they're multiplied together because there's not an addition or subtraction or anything between them. This is multiplication. I undo multiplication with division. Very simple algebra, like algebra 1 here, okay? So we're going to divide the 2.2 to the other side of the equation. Technically, we're going to divide both sides, but in doing so, it's going to eliminate itself on the right. So this is 2.2080396. And we're going to have P equals whatever this division is. So take your calculator to 9860, and you're going to divide by 2.2080396.
64.
If you have more decimals, that's fine.
And the approximate value is $4,465.50.
Does it end up being exactly 50 at the end, Leah? 499, so we'll round to 50. Perfect. Okay. And this is a dollar amount, right? So we are going to use 2 decimals of accuracy and put a dollar sign on there. Okay? So this would be kind of like the idea. I know 9860 is a weird number, so let's just say 10,000 for a moment. Let's say that you were 6 years old and your rich grandmother died. She left you some money. And your parents are going to let you play with some money, but they want to put enough money in an account so that you can have a car when you turn 16. And they decide $10,000 is an adequate car for a 16-year-old, whatever. But the question is then how much money should you put into that account to make that happen? That's legitimately what this problem is about. It's about how much money do I need to set aside right now so that 10 years from now I can have a certain amount of money to do something with it. And that would be an idea of how this would work. Okay? With those considerations, with the compounded quarterly and with the 10 years and the 8% and so forth. All right, let's take a look at one other, no, there's 2 more formulas still. One more formula at this point is called effective annual yield. This is the annual interest rate you receive or pay taking compounding into effect. Now, you may not have heard the phrase effective annual yield before, but I would maybe 98% guarantee you've heard the phrase APY before. If nothing else, you've heard it on a commercial. Maybe you don't know what it means, but you've heard APY. Effective annual yield is APY. Now let me tell you what the A, the P, and the Y stand for. Obviously, Y stands for yield, because that's part of this description already. A is annual, and P is percentage. Annual percentage yield. Okay? So what this is this takes into account that when you put money into the account, let's say, for instance, I put into an account $1,000 today. Well, over the course of this year, however it's compounded, it's going to grow a little bit. So let's say at the end of the year, that $1,000 is no longer $1,000. Now it's $1,005. Everybody with me so far? It's grown a little bit in year one in the bank. I haven't touched it. I just stuck it in there, and it grew a little bit with interest. Well, next year, what will happen is that I will earn interest on not $1,000, but on $1,005, which means I earn interest on the interest that they already gave me. Are you with me so far? Okay. This is the way things work, okay? This is what happens when you put the money in the bank. This is what happens when you take out a loan. Now, I will tell you that I understood in general what this meant, but I'll tell you the first time that it really sort of hit home was when we signed all of our promissory notes for our first loan on our first home. Husband and I bought a $100,000 house, okay? We signed a 30-year note for that house. Now, we're not living in that house. That's several houses ago at this point. We've moved quite a bit. But I will tell you, the first piece of paper tells you how much money in the end you will have ended up paying for that $100,000 house. Care to take a guess at how much it was?
184.2.
It was almost $300,000. Because we were paying interest on the interest. I mean, that's in essence what was happening. Okay? So this was back when interest rates were a little higher. They were about at 7%, which was great then. It's not great now, but it was a fabulous rate at the time. So we had a 7% interest rate, but it really isn't a 7% interest rate over the entire span of 30 years, right? That's what's happening. So what this does, let me tell you why the purpose is for this, okay? The purpose of figuring out what the APY is or the effective annual yield is or whatever is it actually allows you to compare loans or compare savings accounts or whatever. So for instance, let's say you're deciding you're going to purchase a car and you have decided that you need to take a loan for that car. One company, which is not a good idea. I can see Austin already shaking his head. Not a good plan. I agree. Not a good plan. But you've made this decision, and now you're trying to compare worst case versus better case scenarios on loans. Okay? Well, one company offers you a loan, and they offer you a slightly higher interest rate, but they don't compound as frequently. And this loan over here offers you a slightly lower interest rate, but they compound it much more frequently. What this formula I'm about to show you is allow you to do is it allows you to compare the two loans by taking into effect the compounding and the interest rate, as long as everything else was fixed. That is, you still are borrowing the same amount of money, and that is, you're still borrowing it for the same amount of time. Now, if you're not a fan of borrowing, we can do the same thing talking about savings accounts or loan account or accounts like on a CD or something like that, okay? Works the same way. You're still putting in the same amount of money. You're still going to leave it there for the same amount of time. You're taking into consideration how frequently they compound your money, that is, how frequently they give you interest, and what the interest rate is on your money. Okay? Now, you're looking for something different in each situation. I should make that comment, right? If you're putting the money into the account, do you want a higher or a lower interest rate? Higher, yeah, because they're paying you the money, right? If you're borrowing the money, you want a lower interest rate. So you're looking for a different overall effect, okay? But this allows you to make that comparison. So let me show you what this formula looks like, and pieces of it are going to look familiar. You've got y equals for yield. Does that look familiar? It's the same value from the inside of the other formula, right? Yeah. And in fact, it has one more piece in common. It also has an exponent of n on it. It does not have the exponent of time on there at all. The time does not come into play because when you're doing the comparison, the assumption is you're using the same amount of time. Otherwise, it doesn't make any sense to compare them at all. It's like comparing a 15-year mortgage to a 30-year mortgage and saying, I'm paying less money. Yeah, for twice as long. You can't compare quite like that. So that's not the point. Okay, so we're talking about the same length of time. After you do this calculation with the exponent, you subtract off the number 1, okay, which is in essence subtracting off the initial amount of whatever you were talking about. Okay, and then you're multiplying by 100 to turn it into a percent as a percentage yield. Okay. Now, a couple of comments on this. When you find the APY is going to be a close, very close number to the interest rate in the problem already. So if this starts out 2% and you find that the APY is 6%, you probably made an error. Okay? That's the first thing. Second thing, not only does it need to be close, but it needs to be close and a little bit higher, right? Because it's the interest on interest issue. So if you got a number that was 1.98%, again, you've made an error because you shouldn't be getting a smaller percentage rate than you originally had. Everybody with me on that? So jot yourself down a note. You'll know that you're in the right ballpark if you're close to the number 2% and slightly more. Okay? All right, so let's take a look at a problem. It says, suppose a bank pays a nominal rate. We have not talked about the phrase nominal rate. So we're going to do that right now. Nominal rate, also sometimes called, again, you've seen this phrase, APR. If you heard that APR, it's usually Carla people that talk about that too. Annual percentage rate, okay? This is just the R that's in all of my formulas, okay? There's nothing fancy about this number. It's just the R that's in my formulas. So it says the bank pays a interest rate of 2%, that's R, so this is R equals 2%. On a savings deposits, find the effective annual yield if the interest rate is compounded, and the example we're going to do is monthly, okay?
Uh-oh.
All right, so we have y equals, now I'll use yellow. Y equals, I've got my bracket and my parenthesis and my 1 plus. What goes on top of my fraction in this case? 0.02, right? It's that 2% as a decimal. What's going to go on bottom? 12. I'm going to close my parenthesis and make my exponent a 12. Then I'm going to subtract 1 and multiply by 100%. All right, so I promised you that we were going to do one, and here we are. I would like for you to take 0.02 and divide by 12 and tell me what happens.
We got a repeating decimal.
We have a repeating decimal. I told you we were going to get one, right? It's actually okay, because your calculator can repeat all you want without you touching it. So it's going to have a repeating decimal that says what? What does the repeating decimal say? Okay, so 0.0016666666, something like that. Okay, let your calculator continue to say that. Don't round it. Just leave it there. It's fine. And then I want you to hit +1. Now it says 1.00166666, right? That's okay. The calculator can repeat. It can store all of that in its little memory. I don't have a problem with that. So now we've done everything inside the parentheses. What are we going to do next? Do the part that's to the 12th. Not to the brackets part yet completely, but we're going to do the 12th, right? So hit your caret 12 or your x to the y to the x key, whatever you need to hit it to a 12th. And it's going to get worse. It's going to get worse before it gets better. It's all right. Now we've got something that doesn't even look like it repeats, right? Ugly looking, it's okay.
Is it too early to round?
Well, here's two things. Yes, it's too early to round with your calculator. If you wanted to pause and write something down, it'd be okay to write down a rounded value as long as you're not using the rounded value in your calculator. Are you guys with me on that? Don't round. Your calculator can store and keep all those decimals, ugly or not, just fine. Let it. Okay, so at this point now you've got some ugly value that says approximately 3 point something. What does it say right now? 1.02. Okay, so it still says 1 point something. That's fine. And then we're going to subtract 1, right? So you hit -1. Your calculator's just going to keep storing all those ugly decimals, right? No problem. And then what are we going to do? Multiply by 100 times 100. Now, when it gives you this answer, this is the first and only time you get to round for your answer. And your answer is going to have 2 decimal places. We're going to use 2 decimal places on everything. If my math lab tells you to do something different, do whatever it says. But when you're working your problems for me, for your homework, for whatever, and I'll remind you on the test, there will be a blurb on there that says, remember all decimals to 2 decimal places and so forth. Because you're already doing your money to 2 decimal places, so we're just going to do 2 decimal places on everything so we don't have to remember differences, okay? What does it say? 2 point something, because I told you it should, right?
That's 2.018435573
Okay.
2.02%.
Right, so if we round to 2 decimals, it would be 2.02%. Because it had 2.018, right? So the 8's going to make the 1 before it round up. Do make sure that you give that as a percent, not as a dollar, because this is not a dollar amount. This is a percentage. 2.02%. Very, very close to the same value, but slightly more, right? Okay, so that's APY. All right, we're going to look at one more topic in this section, that is continuously compounded interest. Continuously compounded interest, there's a typo on my screen, it says this interest is compounded at a continuous rate as opposed to monthly, annually, etc. When people work on interest rates with mutual funds and whatever, they assume a continuous rate. That's how they make their assumptions. And it makes sense in the context of what they're doing. So there is a financial application to doing this. Banks don't do this, though. So
because of the value just...
Yes, because the value keeps fluctuating. So they just, at the very end of the year, they're going to tell you what the continuous rate was. Exactly. All right, so let me show you what this future value formula looks like. So the A is going to be what you've seen before, and the P is what you've seen before. None of that's any different. A equals P, and then we've got some other stuff after it. The next part's a little bit different. You've got a new letter, and we'll talk about this new letter E in a moment. This new letter E has an exponent RT. So tell me some differences between this and the previous formulas for A equals. I've got an E in it. I already said that. What else is different?
Oh, because it spells pert.
There aren't any, it does look like PERT. There are no parentheses in here because I don't have any addition and subtraction, right? That's different. Then that's actually a really nice thing because it actually makes this problem easier to work with. I don't have to worry about any parentheses. What else is different? There's something missing besides the parentheses. A letter.
Line.
There's no N. There's no 1, yes, but there's no N, right? What did N represent? How many times it was compounded per year? Well, we don't have a number of times per year anymore because this is continuously, so there's no N for that reason. All right, so let me tell you what E is. All the other letters are exactly what they were before. E is actually not a letter. I know. It looks like a letter. It isn't. It's actually a mathematical value. It's a number. It's an irrational number, which we've talked about irrational numbers before. You know another irrational number that looks like a letter. Do you know what it is? Pi. I mean, it's not one of our letters. It's a Greek letter, but it's a letter, right? Pi. Now, here's something you also know about pi. You know that pi does not equal 3.14, correct? What is 3.14? It's a rounded version of pi, right? It's an approximation only. So let me tell you what the approximation is for E. It's about 2.718. But just like when you're doing a problem for circumference or diameter or something like that, something with pi in it, you don't use 3.14 if you're going for accuracy. You're not going to use 2.718 in these problems either. What did you do if you wanted accuracy back in geometry and you were using pi? What was that? You hit the pi button.
So
You're
what's
going to do the
E
same thing.
button?
There's an E button in your calculator. Now let me tell you, it's not a capital E. It looks like a lowercase e because there's a capital E button in many of your calculators too. So look for the lowercase e. If you can't find it, I'll show you where it is on your particular calculator when we're done because I
I
can
can't see
find
a
it.
lowercase e on my
Well,
scientific
Leah,
calculator.
I just said if you can't find it, we'll find it later. Okay? So look for it. If you can't find it, we'll look for it later. But this is going to be the button you're going to use for these problems. So please make sure you do not use 2.718. Please use the actual button E. All right, so we're going to take a look at a problem. We're going to find the present value for the future amount using the data from problem number 3 is what this should have said. We could go back to problem 2, but we're going to use problem 3. All right, so this is the same problem we just did, okay? Well, just a second ago. It had an A equals formula, but we're going to use A equals P e to the RT, A PERT, from problem 3. Now, in problem 3, we were given that the future value was 9860. Do you remember that? Yeah? The present value is what we're looking for. That's the P or the principal, just like it was in the previous problem. We have this E, which is a button in your calculator, agreed. R, what is R in that previous problem on problem number 3?
0.08.
Was 0.08, right. And what was the time?
10 years.
10 years. All right, so first things first, just like before, we're going to multiply that exponent together. Don't get carried away. Don't forget that step. What is 0.08 times 10? That's 0.8. Yes, it is. Now, many of you are going to hit this button E and then tell it 0.08. Some of you are going to have 0.08 and then you're going to hit the button E. It depends on your calculator. Okay? When it gives you an expression, I want to know what that expression is. 2 point.
22.
Good thing I have e to the x power on my calculator.
409.
Okay. And again, we want to keep at least 6, 7 decimals, okay, for accuracy purposes. 2.2255? Yeah. No, my decimals are not being very dark today. All right. We're at the same point we were before when I said there's a little bit of algebra to do. What's algebra you have to do at this point? You're dividing. So you're going to divide by 2.2255409. And what will you find for P? Did you get a value, Brittany?
44,030.
38? So $4,430.38. Compare that to what the answer was on problem 3. That answer was $4,465.50. How does it compare? It's a little less, right? And that's exactly what happens. The more times you compound it, the less you'll have to put in the account, given that all other things are equal. The less I have to put in the account initially to make that happen. Okay, so more compoundings is good if you're saving the money, and fewer compoundings is good if you are paying back money on something. All right. Inflation is the last thing we're going to talk about today. Do you guys like inflation? Do you even know what inflation is? That's the kind of things we think about. So you'll hear the gloom and doom people talk about how if inflation continues, it's going to cost X number of dollars for some product in the future, right? And what they're doing is they're looking at how that product has increased in price over the last however many years. That's inflation. Now, when people talk about an inflation rate, they're actually talking about this one when they're talking about a consumer price index. So they take prices on large numbers of things that people purchase. So bread and milk, ground beef and soup and bananas and apples and stuff. Okay? So they're looking at all of these different products people purchase, and they're looking at how those products have increased in price over time. You all have parents and grandparents who will tell you funny stories that say something like, I remember when the price of such and such was this, right? That's what you're looking at. You're looking at the prices, how they've increased over time. Now, of course, you have to look at how wages increase over time, too, and combat that and see whether or not your money's going as far as it used to be. So it's not a one-way street. But inflation is what we're looking at, okay? So when you hear people talking about the cost of college education going up higher than the cost of inflation, that's what they're considering. They're considering these products as compared to the product of higher education, right? Okay. You guys still writing? We're going to look at one example of this before we pause for today. All right, you guys ready for the one last example?
Not yet.
Not quite? Okay.
Okay.
Okay, everybody else good? I think everybody else was finishing up. Okay, good. Last problem. This says in 2010, a small car cost $18,500. Obviously, that's a very generic statement. Our purpose is really not being specific on the problem, but to just show you how the inflation part works. Okay, so I get it. Find the inflation price for 2020 at 5% inflation rate. Now, you'll notice what this didn't do is it didn't say anything about how things were compounded or how to do the problem per se. Now, it's actually using that continuous rate for the same reason that we would do it for a stock market. Things go up and down and fluctuate at the end of the year. We say, oh, the average overall whatever for the year was done, and we do it continuously. Okay, so we're looking at a continuous rate. So the formula we're using when we're talking about inflation is APERT. Okay, that's the formula for inflation. All right, so we have $18,500. Is that the A or is that the P? That's P. That's the current price that we're paying in 2010. I know it's not 2010. I should probably change my slide. But that's the current price we're looking at. So this is the $18,500. And the A is what we're looking for because we're looking for the price into the future. What's going to happen? What's going to be the cost for the equivalent car then? What's R?
10 years from 2010.
Okay, good. So that's T, right, Leah? Leah said that that T is 10. What about my rate? What's R? That's 0.05. Okay. So the first thing I'm going to do is what? Again, some of your calculators can comprehend this just fine. For those of your calculators that can't, what should I do first? I need to deal with the exponent. I will keep myself from loads of heartache later if I just do it. What is 0.05 times 10? It's 0.5. Now again, some of your calculators will do this just straight across. You can just do this exactly like it's written here. Others of you need to work from sort of the inside out. Again, looking at this is a multiplication fact and this is an exponential fact. We always do what first? Exponentials. That's an order of operations issue. Exponents before multiplication. So I'm going to do the exponent first. So you're going to do e raised to the 0.5 power or the 0.5 power and then hit your E button. And once it gives you that expansion, it's going to look like an ugly expansion, and it's okay because your calculator can store it just fine. And then you can hit times 18,500. Should it be more or less? Should be more. Inflation causes prices to go up. How much more? Well, I shouldn't say how much more. What was the price? And what was the end? Fabulous. So that 18,000, and it's not the same car. We're not talking about buying that exact same car. We're talking about an equitable car, right? So the same small car that you would be buying right now as a entry level, whatever, into college, it meets these certain criteria. It's the average standard, whatever. And then you're comparing that to the average standard, whatever, 10 years from now, which undoubtedly is a nicer car, right? Because things are going to change in the particular car. But it's going to be a middle of the market, whatever, if the first one was a middle of the market, whatever, okay? So it's going from you having to have an $18,500 to purchase that car, it's going to be a $30,500 to purchase an equitable car at that point in the future. Everybody make sense? Excellent.